In this video, we're going to discuss something that's a little confusing to many network engineers, myself included from time to time, and that is how to determine subnet masks. Now first, a little bit of review. You'll recall that IP networks fall into a few general high-level classes. Those are those class A, B, and C networks that we discussed earlier in this course and in the IC&D1 course. Now, in order to efficiently use these networks, it is important to be able to split these networks into smaller chunks so we don't waste address space. Now, this ability to split networks up is not really a huge deal in the RFC 1918 private IP address space, since most networks have IP addresses to spare. I mean, come on, you've got an entire Class A network that's got something upwards of 16 million IP addresses in it. Certainly you can find something in there. Where this does come into play is with public IP networks. When you run a business and you're given a public IP address space, your provider may say, here is a quarter of a Class C network, or here is half of a Class C network. They'll give you an IP address and a subnet mask and leave it up to you to figure out what the usable address range is sometimes. As a result, that's why you have to know how to do this, not just for the exam, but also you need to understand the basics of how this works so that as you're using these subnet tools that I'm going to talk about at the very end of this slide deck, you know how those tools got the answers that they got. Now you'll recall we mentioned this in the IC&D1 exam. We get a lot more in-depth with this here in the IC&D2 exam, and if you proceed forward into the CCNP routing and switching, you'll really touch on this heavily in the CCNP route exam. So as with many things in the networking world, I'm just going to show you how to figure this up using a couple of examples. Now here's the first example. What is the last valid host on the subnetwork 192.168.65.71 with a subnet mask of 255.255.255.240? Now the first thing you'll need to memorize, if you will, is this binary number chart. To those of you that have some experience with mathematics, this won't be a big deal. To those of you like myself who barely made it through advanced calculus in high school, this might prove to be a little taxing after all these years. But you have to know at the very base how to convert a number from decimal to binary. So let's take this IP address that we have here, 192.168.65.71. Now, the way we do this conversion is we start at the very left of the binary number chart and we put a 1 in every column that would add up to 192. So the easiest way to do this, at least in my opinion, is just to start at 128. Well, is the number we're looking for above 128? It is above 128, so this highest bit will be turned on, this 128 bit. So we add 128 plus 64. In this case, 128 plus 64 happens to be 192. So we know that since we've arrived at our answer already, all the rest of these bits are zeros, so the correct answer is 110000000. So let's look at 168. Well, again, the number is above 128, so we leave that bit on. 128 plus 64 we already know is 192, so that's too high, so this bit is a 0. 128 plus 32 is 160, so we're getting close. We know that this is 160. We just need 8 more bits. In this case, it's going to be this 5th bit here, the number 8. So in this case, the answer will be 101010000. The next number is 65. That's obviously 64 plus 1. So the correct answer is 01000001. And then 71 is simply 64 plus 7. So in this case, it's 01000111. Let's see if we're correct, because I figured this up using calculator, and let's see how close I got. Hey, I was exactly right. Funny how that works. So now we have our IP address in binary. I'm not going to go through reading all of that again because I don't want to put you to sleep. The next thing we do is convert the subnet mask to binary. Now this is a lot easier because the first 3 octets are all 255s, and we know that 255 is 8 bits, so it's 3 octets of all 1s, followed by 1 octet of 4 bits on, and we got that just by 128 plus 64 plus 32 plus 16 equals 240. The next step we do is to binary and the network address, or the IP address in this case, and the subnet mask. And when you binary and 2 numbers together, you write the numbers one over the other. If both bits are a 1, then you get a 1 in the output. If either of the bits are a 0, you get a 0 in the output. In this case, this gives you the network address. If you add up all of these bits, it comes to 192 192.168.65.64. So that's the network address. You convert the host portion, the last 4 bits here that you got from the subnet mask, to all ones to get the all ones address or the broadcast address. In this case, it gives you 192.168.65.79. And in our case, the last usable host is 1 less than the broadcast. So the answer to this example is 192.168.65.78. That is the last valid host on this network with that subnet mask. So picking up where we left off, we are in the middle of determining subnet masks. And we saw here on this slide deck the longhand way to do it, or what I consider to be the hard way to do it, because it's a lot of binary conversion. Let's look at another way to get the same information. And we will do that with another example. What is the broadcast address of the network 192.168.73.128 with the subnet mask of 255.255.255.240? Again, we will need our binary number chart just because we will have to do a little bit of binary math. So step 1 in this method is convert the subnet mask to binary. And in this case, since the first 3 octets are all 255s, all we're really interested in is the last octet. Now, if the subnet mask broke here in the 3rd or the 2nd octet, then obviously you'd be interested in the last 2 or 3 octets. But for our example, we only care about this last octet. And you notice it's the same subnet mask. So our binary math for this is exactly the same as on the previous slide. Now let's examine this subnet mask. Now we have 4 bits in our subnet mask here in the portion. That 4th one is in the 16 position in the subnet mask in this binary number chart. So the last bit being in that position, we know the subnets are 16 hosts big, meaning that our subnets will advance or increment on the number 16. So now we simply count the subnets to find the range. Our first subnet is 0 through 15 because the new subnet starts on 16. The next subnet is 16 through 31 because the next subnet starts on 32, so on and so forth until we hit the range for the network we're looking at. In this case, it is the network that has the .128 host in it. .128 happens to be a network address. We know that 128 plus 16 is 144. We take away 1 because we want the last host on this subnet, and it's 143. So the broadcast for that network is 192.168.73.143. Again, this is personally how I solve these problems if I don't have a calculator or have a subnet cheat sheet around, which we'll get to on the next slide. Some people I've shown this to, they just kind of look at me like I have 3 eyes. And they say, how in the world can you do that? How do you know that? It just doesn't make sense. And again, some people's minds works different ways, and you have to find a method that works for you. So long as you get the right answer and you can duplicate getting the right answer, it's all good. So with all that being said, there are several different ways to solve these subnet questions. Again, we've shown you 2. I've seen at least 7 just in the past year alone. You find a method that works for you, you learn it inside and out so that you can do it cold. All you have to do is write down that binary map, if you will, that 128 through 1 that we've used on the previous 2 slides. And if you know your method and you know it inside and out, all you need is that binary chart. Honestly, once you learn the math behind the problem, there's 3 million websites and cheat sheets you can use to help you determine the proper subnet masks and ranges and so on and so forth. There's the 2 that I use most often. I especially like that bottom one there because it's got a little JavaScript application that pretty much figures all the stuff up for you. It even figures up the Cisco wildcard mask, which you'll use when you set up ACLs, which we'll talk about elsewhere in the course, of course. But honestly, if you go out to your favorite search engine and you search for binary subnet mask cheat sheet or binary subnet mask calculator, you'll end up with, again, about 3 million results when I looked at it in one search engine. And that concludes our discussion of determining subnet masks.